hopefully you have all realized that Matthias Stahl won't be making his presentation today, but at a later date instead. So today I am going to present a talk that I did a couple of months ago internally at NGI, and it's about good coding practices based on a book called Code Complete. So I will just share my screen so that you can see the slides. Okay, hopefully you can all see the slides now. So Code Complete is widely considered one of the best practical guides to programming. And at 800 something pages, it was a bit of a challenge to distill it into a reasonable presentation. So I've obviously had to cherry pick what I thought were some of the most relevant bits from the book. But I would warmly recommend everyone to pick up this book because it's a pretty great read, and it also has plenty of topics that I won't be able to cover today. Now, the book focuses a lot on managing complexity and making code readable. But before it goes into actual coding practices, it talks a bit about prerequisites and design. So I will just talk about this briefly to start. So why should we even care about this in the first place? Why can't we just code away as soon as we have an idea of a new project? Well, I think that this quote from the book demonstrates the value of the design process quite well. So it says that we try to solve the problem by rushing through the design process so that enough time is left at the end of the project to uncover the errors that were made because we rushed through the design process. So before starting on a new project, it is important to take some time to think about the problem that you're trying to solve. So for instance, if you're lucky, someone might have already solved the problem and you could just simply use their solution. Or if you don't think through the problem thoroughly before you begin, you might end up solving the wrong problem altogether or having to rework the code several times. So for instance, you might want to build a Trojan horse, but you end up building a Trojan rabbit. So it's a good idea to spend at least a little bit of time to think through the project before starting to code. According to the book, the most important goal of design is to manage the complexity of the software. This can be achieved by focusing the design on simplicity. Now, the main tool that we have to handle complexity is to divide the code into subsystems. So by dividing the program into classes and routines, you allow your brain to focus on a smaller amount of the system at once. Now, when you first start out on your journey into programming, the concept of classes can be pretty confusing. But simply put, a class is just a collection of data and routines that share a cohesive and well-defined responsibility. So it's kind of like a special interest club. Two concepts to keep in mind when working with classes are containment and inheritance. So containment models has a relationships. For instance, the class dog has a component tail. Inheritance, on the other hand, models is a relationships. So one class is a specialization of another class. In this case, dog inherits from the animal base class. And this means that the dog class can automatically use all of the components of the animal class. As you can see, inheritance is a very powerful tool, but it also adds complexity. So we should try to be careful when we're using it and especially avoid creating deep inheritance trees because they can be very hard to keep track of. Classes can then be further subdivided into routines and data. So we're going to have a closer look at some considerations for writing routines. A routine is an individual method that can be invoked for a single purpose. The book argues that a routine should only do one thing and do it well, which means that sometimes routines end up being very small. This might seem excessive, but it can actually help make the code more self-documenting, as in this example. So here we have some piece of code that checks if someone is a witch based on if she weighs as much as a duck. It looks fairly simple already in case 1. It's only 4 lines of code. But by putting the check into a well-named routine, we can make the code more abstract. In case 2, we don't have to know the details of the routine to know what's going on in the main body of the code. So we go from keeping track of 4 lines of code to keeping track of only 1 line. So arguably it's fine to have very short names, but it's also a good idea to stick to an upper limit. And the book recommends keeping routine lengths around 1 screen long to make it easier to keep track of what it contains. Now, in order for all of this to work as intended, which is to make the code more readable and less complex, we need to make sure that the routines are sensibly named. But how hard can that be, really? Well, actually, coming up with sensible names for functions, variables, classes, etc. is one of the most challenging parts of writing readable code. So let's have a quick look at some things to consider when naming functions. Now, the main thing that the name should is that the name should describe everything that the routine does, which, as I mentioned, should only be one thing. So if you find that when you're naming a routine, you want to call it do this and that, for example, compute total and open output file, then you might want to consider splitting this into 2 separate routines. Another thing to consider is to make the routine names as long as necessary. So longer names are more of a pain at write time, but they can be of great use at read time. And one of the key points in this book is that code is read many more times than it is written. Having descriptive names also means that you should avoid using vague names or differentiating between routines only by number, like in these cases. With names like this, you don't know just by looking at them what it is that they actually do, which means that you have to go and look at their code to understand what is going on. This in turn means that you have to keep a larger chunk of the program in mind at any one point. So now we have an idea about why we want to use routines and why naming them sensibly is important. But what about variables? Even though variables may be easier to understand than routines and classes, there are still some important things to consider. One important concept when it comes to variables is the scope. And the scope is a way of thinking about the celebrity status of the variable. How famous is it? So to what extent is it known and can be used throughout the program? An example of a small scope would be a loop index, and an example of a large scope would be a global variable. 2 measurements relating to scope that we can look at are the span and the lifetime of the variable. Now, the span is how closely in the code the variable is referenced, and the lifetime is how long the variable is kept alive. So here we have an example of short spans where the variable is referenced every other line or so. Here we have longer spans where it's less frequently referenced. And we also have an example of long lifetime where the variable is initiated at the top of the code and then it's used all the way down to the bottom. And here we have some shorter lifetime where we only use the variable at the very top of the code. It's generally a good idea to keep spans and lifetimes as short as possible, as this makes it easier for someone reading the code to keep track of the different variables. Now let's look at some considerations to make when naming variables. So the most important thing to consider when naming a variable is that the name should fully and accurately describe the entity that the variable represents. Generic names like X are, in most cases, too general, since they don't tell us anything about what information the variable holds, unless it's a mathematical thing. So let's have a look at this example. It's pretty easy to tell what this code does, right? It concatenates some strings, but the purpose of the code isn't clear. And this is clearly an exceptionally bad example, but it's not uncommon that we prioritize convenience at write time over readability. So in this example, all the variables are too short and generic. While this might be fast to type, and you might be able to remember what the variable represents while you are writing the code, when someone else comes along, or even yourself, like 2 weeks later, they will have no clue what the code is meant to do, and they will likely wonder who the heck Tim is. So let's look at how we can make this code a bit clearer. Right. Now you can quite clearly see that the purpose of this code is to concatenate a string for a breakfast order of some sort, mainly consisting of spam. So as you can see, some of these variable names are quite long compared to what they were before. So how long should a variable name be? Well, as with routines, too short names don't convey the meaning, but too long names are hard to type and can also reduce the readability. Ultimately, names should be as descriptive as possible while still being readable. Sounds simple, but yeah. That being said, there are cases when short names are fine, for instance, for short scopes, like using I as a loop index. Right, so now we've talked about how to name variables, but what about the data that those variables hold? As you probably know, data can be of several different types. Some fundamental ones that you are probably familiar with are integers, strings, and arrays, just to name a few. One thing to consider is to avoid using magic numbers and strings. And these are literal numbers or strings that appear in the middle of a program without any explanation, like the 3 in this example. So avoiding these makes it easier to make changes throughout the code, and it also increases the readability. Luckily, removing magic numbers and strings is pretty easy. You just replace them with a named variable or constant, like so. As I said, this makes the code more readable since it's easier to understand what a named variable represents than a random number, given that the variable is sensibly named, of course. As a rule of thumb, 0 and 1 should be the only literals to appear in the body of a program to be used for things like incrementing and decrementing and starting loops. Now let's move on to statements. Statements can be as simple as a line of code that expresses some action to be carried out. Now, that might sound simple, but if we're not careful, it can turn ugly quite quickly. We're going to have a brief look at two kinds of statements, conditionals and loops. A conditional is a statement that controls the execution of other statements, like if else, you might be familiar with. For conditionals, the book argues that you should consider putting the nominal case first, which is the case that you would expect to happen, and to put it after the if clause instead of after the else clause. This should make the path through the code clearer and increase both the readability and performance. So let's have a look at this example. Here we have some code where we're randomly checking for errors along the way. It's kind of hard to follow the logic of this code. So let's follow the guidelines and see what happens to the readability. This is basically the same code. We've just slightly rearranged it. And as you can see, it is a lot easier to follow the logic in this version. And as a bonus, it looks a lot nicer. That's all I have to say about conditionals. So another type of statements is loops. Now, loops can be pretty complicated and the logic of them can be hard to follow. For this reason, it is important to keep them simple to help the readers of your code, including yourself. So what are some ways in which we can manage the complexity of a loop? Well, the book mentions a number of things that we can do. And for reference, I have listed some of them here. But don't worry, I won't go through all of them. One thing that you can do is to treat the inside of the loop as you would a function. So consider things like having it perform only one function and making it short enough to view it all at once. It's also a good idea to limit nesting to a maximum of 3 levels. And if it grows very big, you can consider moving bits of it into routines. Now, now we have talked a lot about how to reduce complexity and improve readability by using classes and routines, naming things sensibly, and making statements easy to follow. Well, what else can we do to improve the readability of our code? Well, what about the actual layout and style? So let's have a quick look at why good visual layout matters. Imagine if you're reading a book and there's no formatting. I imagine we wouldn't enjoy reading as much if all books look like this. So why should code be any different? As in books, good visual layout in code shows the logical structure and improves the readability. So which is the best practice for layout and style then? Well, there isn't really a right one. There are many different conventions, and it's often a matter of personal taste which one is the best one. The point is that the details of the coding style is much less important than the fact that the code is structured consistently. Just keep in mind that it's also possible to overdo conventions, so try not to be too rigid. So now we have talked a lot about managing complexity and making code readable. What more should we think about when we're writing code? Well, how about the procedure that we use when we're writing the code? Is there a way to be more structured, for instance, when starting on a new project? One technique mentioned in the book that I particularly like is the pseudocode programming process. It's a method that can help reduce the work required during design and documentation, and also improve the readability of both. To summarize the process, when you begin a new piece of code, you start by writing it in pseudocode. Pseudocode should be English-like statements, free from any language-specific syntax. And it should be written at the level of intent. So, for example, instead of writing increment count by 1, you would write keep track of current count. At some point, you will feel like it would be easier to just write the actual code than to keep adding any more pseudocode. And it's at this point that you should start coding. So you'll take your pseudocode and start by writing the routine declaration. Then you turn the pseudocode into comments and fill in the code below each comment. When you're done, you check your code mentally to see that it works, and then you repeat these steps as needed. Now, this might seem like a lot of extra work, so why should you even bother with this? Well, there are several benefits to this process. For instance, during the design process, which shouldn't be skipped, pseudocode is easier to read and change and also explain to someone until you have the final design nailed down. Another benefit is that since you turn your pseudocode into block comments, you'll end up with very nicely documented code. Now let's see what this could look like with an example. So here we have written some pseudocode for a function that should take some sequences and return the length of the longest one. Very useful stuff. Now let's implement this using Python. So once the pseudocode is finished, let's add a routine declaration, or since this is Python, the function definition. And next we turn the pseudocode into comments. Then we go ahead and fill in the code under each comment. And when you think you're done, you should check the code and do this mentally by checking the routine for errors and making sure that you understand what it is that you have written. As you've probably noticed, the variable and function names look pretty bad. So let's fix that as well. So that's a lot better. Now, you might have noticed that when we cleaned up the code, we also removed some of the comments. This is because good code is its own best documentation. And if that's the case, then there's not really any need for comments. Comments are another thing that you need to maintain and keep track of, because if they are old or poorly written, then they can actually be more harmful than helpful. Comments should say things about the code that the code can't say about itself. So good code doesn't repeat the code or explain it, but instead they clarify the intent of the code. And perhaps most importantly, if you have a piece of tricky code, then you shouldn't explain it in a comment. Instead, you should try to rewrite that piece of code so that it's no longer tricky. That's all I have for you today. So to summarize some of the key points from the book, the most important and challenging thing to consider when writing code is how to manage the complexity. Code is read way many more times than it is written. So make sure that to make it as readable as possible. Think through the project before you start to program. And finally, conventions release mental resources that you need to focus on more challenging aspects of the programming problem. I warmly recommend this book to anyone, regardless of your level of experience, because there's definitely something in there for everyone. It is very thick, but it is not at all as dull as it looks, and it was actually pretty quick read, considering its size. Now, if you do decide to go for this book, and you find that you don't agree with the contents, it does have a more practical use, as demonstrated here by the person who I lent my copy to. Great. Thank you all very much for listening, and I'm happy to take any questions.
Hi, Sara. Thanks for a brilliant talk. Out of all of these recommendations, I'll be a bit cheeky here, which of these do you break the most frequently?
Yeah, most of them. Yeah, I mean, it's hard to come up with good variable names and things like that. And I'm also not a very experienced programmer, so it's sort of hard sometimes to balance trying to write good code and trying to make the code work, so to speak. So yeah, but it's nice to have some guidelines and to keep that in the mind. Any other questions anywhere? Okay, then, oh, Fran.
But actually, Phil corrected me on something, which is when you have a flow from where you use the result from one function in the next one. And you can either make that a variable and you output it from one function and then you put it into the next, or you can just use it as a self. Mm-hmm. I personally, well, the way I had it was that I put it in a variable because I thought it made it more readable, because then I know exactly what goes in the next function. But I'm still not sure which one of the two is better.
Yeah, I'm not sure actually. I guess that would depend a lot on the situation. It's a good question. You have the book though. You can check.
Yes, but the book doesn't say what I have to do in this specific situation. It gives general guidelines saying that you should make it less complex as possible. But for me, both of them will actually reduce some complexity. It's just a different kind. Yeah. So I wasn't sure. I thought I asked the master.
Yeah, that's Phil.
The risk of being a hypocrite, because I can't remember what I suggested you change it to. My rule of thumb is if you use it more than a couple of times, then usually I assign it as a class variable, as a self dot something. And if it's only being used once, then you can pass it. You'll probably tell me that's what you did.
Yeah.
Hopefully other people can unmute yourself. I don't know if anyone's having difficulties with that, but use the chat or raise your hand if you want to ask a question.
Yep. Oh, now I can see the chat. Cool. Any questions over on YouTube? Guess not. No, I managed to do something stupid. Okay, well, I guess we can end it at that then. And if you have any other questions, just feel free to Slack me or email me or however you like. Cool.
Who do we have next week?
Next month is Maxime. And he is going to tell us about continuous integration, I think. And I'm sorry, but my computer has gone very strange.
I think if we're done, I'll wrap up the meeting.
Yes.
Thank you very much, Sarah.
Yeah.
I'll thank you as you're normally the person who does that.
See you all.
Thanks for joining, everyone.